Hello, my name is Landon, and this video is on electrochemistry, specifically half-reaction practice problems. This video is more geared towards those who learn well by watching other practice problems being worked out. So, first of all, what is a half-reaction? This should be review, but just in case you forgot, we have two different types of half-reactions. We have the oxidation half-reaction, and we have the reduction half-reaction. An example of a oxidation half-reaction would be copper being oxidized to copper 2+ plus 2 electrons. A reduction reaction would be the opposite of that. It would be Cu2+ plus 2E- goes to copper. This right here, these are two very essential ideas, and you will see how important they are as we work out the practice problems here in a bit. But before we do that, let's go ahead and move on to some rules that are involved in balancing half reactions. So here are the steps that you want to keep in mind when balancing half reactions. So you can see we have two sets of steps here. The first being for an acidic solution, the one with less steps out of the bunch, and the other one for a basic solution. Since these problems are kind of lengthy, we're going to stick to a basic solution problem, mainly because it encompasses all the same steps as the acidic solution, but instead we just do something different at the end. So with that, let's go ahead and move on to some practice problems. Okay, so first to start off this problem, we must first split this expression into its half reactions. So I'm going to first identify the common elements or compounds in either both the reactants and the products. And I can see that SbO2 and Sb, they look similar because Sb is there. So I'm going to say that this is going to be my first half reaction. So Sb makes SbO2-. My second half reaction is going to be just with the other two compounds. So O2 is going to make H2O2-. Oh, no, minus sign there. Okay, so now that we've gotten that, we move on to the next step. So let me space these out a little bit, and we will start with the Sb half reaction. So with this, the first step is to make sure that we have the same amount of the key element on both sides. So anything besides O and H. So in this case, that would be Sb. So we have the same amount on each side, one Sb on the reactant side and one on the products. So we're good on that front. With that, let's go ahead and go to the next step. So the next step is going to be to balance out the O's. So in order to do that, we're going to add water molecules. So we can see that there are two O's on this side. So we are going to add 2 H2O molecules on this side. And that will be, so plus H2O, let me just write this out as 2 H2O plus Sb goes to SbO2-. Now that we've done that, we need to balance out the hydrogens on both sides. So since we just added 4 on this side, we are going to add 4 H pluses to this side. So now that we've done that, we are going to make sure we have the same amount of each element on both sides. So we have 1, 2 O's, we have 4 H's, so 1, 2 O's, 4 H's, and we have 1 Sb. So on that front, we're good. We have balanced this equation. Now we must balance the charges. So as you can see, we have a negative charge here, and we have 4 positive charges here. So because there are 4 positive charges and 1 negative charge, we can just add those together, and we get a 3+ charge on this side. And since there are no charges on any of the compounds or ions over here, we don't need to worry about that. So we are going to go ahead and say this is 0. Now since we're going to be adding electrons, we only can decrease the value, so therefore we have to add it to this side. So we're going to do plus 3 electrons, and 3 minus 3 is going to be 0, so in the end that's just going to be 0. And therefore this is now completely balanced. Let's move on to this other one. So this right here, first of all, we're going to start with the O's. Since the O's are already balanced and we don't have any key elements over here, so we can see there's 2 O's on this side and 2 O's on this side, we can just right on move to the hydrogens. So we can see there are 2 hydrogens on this side. Therefore, we're going to have to do a plus 2H plus on this side. So now that we've gotten that, we are going to now balance out the charges since we have the same amount of particles on this side as we do on the other one. So in order to do that, since there is a 2+ charge on this side, summing up all the charges here, on the reactant side and on all the product side, we have 0 on the product side, and we have a 2+ on the reactant side. So remember, only way we can go is down, so we're going to add 2 electrons to the 2+ side, therefore making that 0, and now we can start to add these two equations together. Now remember, before we can add them, we must balance out the electrons so that way they cancel out when we add them. So we can see right here there are 2 right there and there are 3 right there. So since none of them divide each other, we are going to have to go with the least common multiple of the 2. So in that case, that would be 3 for 2 and that would be 2 for 3. So let's go ahead and do the SB reaction first. So since this is 3, we're going to times the whole reaction by 2, therefore making 4H2O plus 2SB going to 2SbO2 minus plus 8H plus 6E minus. All right, so now that we've done that, we're going to go on to the OH reaction, or H2O2 reaction. So with that, we can see that this is going to be 2, so that means we're going to have to times the whole equation by 3. When doing that, we're going to equal 6E minus plus 3 times 2 again, so 6H plus 3O2 equals 3H2O2. Okay, now that we've done that, we can start to add these two equations together. So we can just go ahead and cancel out, actually I'll do that in a different color. We can cancel out these electrons right here. Since they are on both sides, we can cancel them out. So from here, we are going to start to add these. And so we got 4H2O plus 2SB plus 6H plus 3O2 goes to 2SbO2 minus plus 8H plus 6E minus. Or nope, we got rid of the electron, so we don't even have to worry about that. All right, now from here we are going to combine or get rid of like expressions or like reactants or products. Let me go ahead and erase this, make some more room. Get a bigger eraser. Okay, so we can see here that we do have a couple like reactants and products, those being the H's. So since we have 6 on that side and 8 on that side, we can go ahead and I'm just going to erase the value right here, no sense in writing it again. We can just go like this, since this is going to be 0 now, and this is going to be 2. Now, if this were an acidic solution, this would be all we would have to do. But since this is a basic solution, we have one more step, and that is neutralizing all of the H pluses with OH minuses. So we can see there are only 2 H pluses. Therefore, we must add 2 OH minuses to each side. Remember, what you do to one side, you must do the other. So from that, we're going to get 4H2O plus 2SB plus 3O2. That's going to equal 2. Oh, we got to add in the plus 2 OH minus. That is going to equal 2SbO2 minus plus 2H2O. Now the last thing that we have to do here is, again, we need to cancel out the like products and reactants. In that case, that's just going to be water. So we can get rid of this guy over here entirely, and we can replace this coefficient with A2. And now that we have all, you can see the charges are still balanced. We still have a 2 minus charge on both sides. And now that we have only OHs and no H pluses, we have officially balanced out this basic solution reaction. That is it for this video. Thanks for watching.